All right, we got 1.5 here, equations. So we're going to analyze the different equations and know how to solve them. So we'll start off here. These ones are called linear equations, the ones where everything is in the first power. So you can see these first three, all the x's or variables. Actually, we got a t, a p, and an x, but they're all first power. So for these ones, you want to get kind of all the numbers to one side and all the variables to the other. It doesn't really matter which side you do it to. So I'm going to go ahead and add this t over to this side. And then we'll add the 13 over to this side. So that'll cancel out here and here. And we get 5t plus t would be 6t equals, and then 12 plus 13 would give me 25. And then I would just divide by 6. That would cancel that out, and that would be my answer there. You could type it into a calculator and get a decimal for it, but most of the time you're just going to leave it as a fraction, so I got 25 over 6. Okay, let's take a look at number 2 then. Let me clear this off. So for number 2, do have some parentheses over there, so we should distribute into the parentheses first of all. And distribute that -3, so we get 3 minus p plus 4. When we distribute a negative, it just switches the sign. Okay, 25 minus p. Now, if we're going to do the same thing, we would get all the variables to one side. I would add p over to the left-hand side. And then to get all the numbers to the right-hand side, I would subtract 25 over here. So that everything cancels over here. I get 0. My variables cancel over here as well. So actually all my variables are gone. This is kind of a special case. But let me see what number is left over. That is important. So I got 3 plus 4 is 7. And then 7 minus 25 is -18. Now, when all of your variables cancel on these ones, if it leaves you with a true statement, then it's infinitely many solutions. If it leaves you with a false statement, which I would say this is a false statement, 0 does not equal -18, then that's going to be no solution. Okay, let's take a look at number 3 then. I'll solve that one. Okay, so for number 3, once again, I got some parentheses here I should distribute. Okay, so this one I'm going to distribute the -2 in there. So I'm going to say 5 minus 2x plus 10 equals, and then I'll distribute the 1/2. Now, multiplying by 1/2 is really the same as dividing by 2. So I would say that's -2x plus 15. Okay, and then if I do kind of the same thing here, I will add 2x to both sides. And then I'm going to subtract this 5 and subtract the 10. So if I kind of think of it like that, -10 minus 5 over here. So we see these cancel, cancel, cancel. I get 0. These cancel, and I have 15 minus 10 minus 5, which I would also say is 0. And so this one leaves us with a true statement, 0 equals 0. And so this one we say infinitely many solutions. Awesome. Okay, so now we're going to scroll down here, and now we're going to do quadratic equations. So quadratic equations are equations where we have it's a second degree. We have a second power somewhere. Now these ones we need to get one side to 0. So we don't want to just put the variables on one side and the numbers on the other. It doesn't work for this type of equation. When we have this squared, we want to get one side to 0 first. And then we're going to try factoring. Factoring sometimes works. And then if that doesn't work, we got quadratic formula. So we'll use that as well if factoring doesn't work. It's a little bit more difficult, I think, more time consuming for sure. So that's why I try factoring first, but sometimes factoring doesn't work. Okay, so number 4 here, we want to get one side to 0 first. Now, a little advice, not necessary, but it makes it easier. I always like my squared term to be positive. So you can move everything to the left or the right. But this one, my squared is positive on the left. And so I'm going to move everything to the right. So that means I'm going to add 48. I'm going to minus 14r. And so I'm do the same thing on the left side, minus 14r. And I would just put it in order. I'm going to put the r squared first, then the minus 14r, and then the plus 48. And that's going to be equal to 0 since these guys cancel out. Okay, so now we're going to try to factor. We'll do a times c up top is 48. B on bottom is -14. So we gotta think of two numbers and multiply to 48 and add to negative 14. I thought about negative 6 and negative 8. That does work. We have nothing in front of our r squared, so we can do the shortcut here, r minus 6, r minus 8. We're going to see next problem number 5. We cannot do the shortcut, so if you want to see what it looks like without the shortcut, we'll see that on number 5. And now that we're factored equal to 0, we can set each one equal to 0 individually and solve. So for this one, I would add the 6 and say r equals 6. This one I would add the 8 and say r equals 8. Okay, so now let's go on to number 5. Okay, let me erase some of this. Okay. So for number 5, I see I have my squared variable is negative there on the left side, which I don't like that as much. So I'm going to go ahead and move that over to the right-hand side by adding it. So you can get either side to 0 that you want. So I always try to do that kind of strategically to get my squared variable positive. So that's going to look like that with these canceling out. Okay, so now I need to factor here. So we need to think of two numbers that multiply to negative 12 and add to negative 4. Because remember up top here we have a times c. And our a is 4, c is negative 3. And so that's sounding like negative 6 and positive 2. Now, this one, because we have that 4 in front, we cannot just say w minus 6, w plus 2. The way I do this is using kind of a grouping technique. So I rewrite this first term just as is. Whoa, try to write it better than that. 4w squared. Okay. And then this middle term I split up using these numbers from my x over here. So I'm going to call it negative 6w plus 2w. You can see that still is negative 4w, just kind of split into two pieces, and you want to just use those numbers from the x, and then I'll bring down this minus 3 as well. Okay, now we want to use the grouping technique here. So put the first 2 in a group, second 2 in a group. What can I take out of the first group is a 2w. They can both divide by 2. And they both have a w, so it's going to leave me with 2w minus 3 on the inside. The second group looks like I cannot take out anything. Now when that happens, you have to either take out a positive 1 or a negative 1. If this third term is positive, we're going to take out a positive 1, which will give me 2w minus 3, which is important because those parentheses match. And so now we can write the 2w plus 1 that's in front of each parenthesis as 1, and then the 2w minus 3 as the other one for the stuff that's inside. So that's our factoring technique when we have to use the grouping. Now, though, I do need to solve this, so I want to say 2w plus 1 equals 0, and then 2w minus 3 equals 0. Once I'm factored equal to 0, I can split it up. So this one, if I subtract the 1, would be 2w equals negative 1, and then divide the 2 would be w equals negative 1/2 as one of my answers. And then the other one, if I add the 3, 2w equals 3, and then w, if I divide the 2, equals 3 over 2. So there's my two answers on that one. All right, let's move on to number 6 now. All right, so for number 6, for this one, all right, same idea. All right, we got a quadratic. We got to get one side to 0. My squared variable is already positive, so I'd subtract the 4 over here. Now that's actually going to cancel on the left-hand side as well in this case. So you can see this one I have no c. So I actually can factor this one. It's just a GCF. They both have an x in common, so I can take that out front. And then since I have a variable pulled out front, I can set that equal to 0. If you just have a number GCF'd out front, you don't need to do that, but a variable you do. And so this one was saying x minus 5 equals 0. So I would add the 5 and say x equals 5. This one is really already solved, so those are my two answers on this one, x equals 0 and x equals 5. All right, let's take a look at number 7 now. So for number 7, what are we going to do here? I've got another quadratic. Let's get one side to 0. I want my squared positive, so I'm going to move this stuff over. So that's going to be 9m squared minus 30m minus 54 equals 0. Now, I think we have a GCF here of 3. So I'm going to do 3 parentheses, 3m squared minus 10m minus, let me see, what would that be? 54 would be 18, yep. Okay, equals 0. Now I can try to factor the inside now. So now my a times c would be 3 times negative 18, which is negative 54. And then b would be negative 10. Now I don't think that there's anything that can multiply to 54 and add the negative 10. Let's see what multiplies to make 54. So 1 times 54, obviously that's not going to, it should really be subtracting to make 10. 2 times 27, that's not going to work either. 3 times 18 is not going to work. Does it divide by 4? No. 5, no. 6, yes. 6 times 9, that's still not going to subtract to make 10. So no way this is going to work, so we are going to have to use quadratic formula. Quick reminder here on quadratic formula. It is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so I can use my a, b, and c. You could use this is a, this is b, this is c. But what's better is using these ones. You'll get the same answer, but it'll just be kind of less simplification, less work if we use the smaller numbers, right? So I'd recommend using the smaller numbers, all right? Although, again, those bigger numbers would have worked. Okay, so let's go ahead and plug it in. So it says x equals negative b. Now my b is negative 10. I kind of more think of that as opposite b, so I'm just going to put it in as a positive 10. And then in here I got b squared. Now remember, negative 10 squared, negative 10 times negative 10 is positive 100. That b squared should always be positive. I kind of just do that in my head usually because I don't want to mess it up, especially if that b is negative. All right, and then we got minus 4 times a is 3 times c is negative 18 all over 2 times 3. Okay. Then I would calculate the inside of the radical here. You can use a calculator for that, I would say, for numbers this big. But I kind of think of it here. I know that this minus and this minus are going to turn into a plus, so this should be more than 100 in there. Actually, okay, so what is it? Can I do this in my head here? 12 times 9 would be 108. Or what's 12 times 18? Let's look it up. Alright, it's not going to work for me. I'm going to grab my calculator. Times 18 is 216, so this would be 316 in there, divided by 6. Okay, and then kind of our rule here is we're not allowed to reduce these two together. If we're going to reduce those two, we also need to reduce it with a number in front of the radical. And so what we need to do then is we need to try to break down this radical and do what I call look for twins. So if I break down 316, I know 316 can divide by 2 because it's even. So we can call it 2 and 158. And then I can divide 158 by 2 again. 2 and 79, and then 79 is prime, so I can't break it down anymore. So since I have twin 2's here, that's a 2 times a 2 is really a 4, and so what I can do is kind of see it as the square root of 4 on the inside, and so I can put it just a 2 on the outside. So the 2's kind of go outside but combine, and then I always say the loner stays in the house. So we're going to write it like that. Okay, and so now we can actually reduce it, because if you're gonna reduce, you have to reduce these three numbers all together. I like to make a little heart around it since I heart the quadratic formula. And so if we do that, we can reduce that by 2. All of those numbers can divide by 2, so that's gonna become 5 plus or minus. And then it would be 1 times the square root of 79. Now whenever it's a 1, I just wouldn't put it there. If you have a 1 in front here, like where this 5 is, you do need it. That's like an adding 1, but this one would be a multiplying 1, so I don't need it, and that's all going to be over 3. You can see I still do get two answers here. You kind of think of it as 5 plus radical 79 over 3, and then 5 minus radical 79 over 3. All right, awesome. So that one is done. You used quadratic formula on number 7 because it didn't factor. Okay. Now, number 8 is kind of actually another special case here. Number 8, kind of what I see here is we have no b value, if you take a look. We're missing that b value. We have the a is 2, we have the c is negative 10, but we don't have that regular x because that's our b value. Now, whenever you have no b value, there's actually an easier way to solve it. You can isolate x squared and then take a square root. And then whenever you take a square root, though, you use a plus or minus on the number side. So it's whenever you create a square root to solve an equation. So for this one, I would add the 10 over. So 2x squared equals 10. I would divide the 2. So now you can see I've isolated the square root there. I isolated the x squared, and now I'm going to take a square root. And so I would say x equals, oh, that's a weird equals, triple equals. No, we don't want that. Equals plus or minus the square root of 5. You could get a decimal for that in the calculator. Usually you're just going to leave that as a radical like that. So that looks good. If you kind of think about it here, if I had rad 5 squared just turns back into regular 5, but negative rad 5 squared, a negative times itself would turn into a positive 5 as well. So that's why we get two answers yet again. All right, next up here, we're going to talk about kind of the force of gravity. It creates a quadratic function, so we can apply this. So that in this formula, the v sub 0 is the initial velocity. Okay, h sub 0 is the initial height. So let's go ahead and try these out. So it says cannonball is shot from the ground straight upwards with an initial speed of 800 feet per second. So that's going to be my initial velocity. Since it's shot from the ground, that is my h sub 0 is 0 because the ground height is 0. And so I'm going to write this equation. So I got negative 16t squared, and just from that formula up there, plus 800t. So that's just me plugging in that initial velocity. And you can notice I put time right there. I wrote it sloppily. I'll write it again. But it's probably better to write it without the parentheses. Probably just a little bit less confusing when you actually plug in the number. There's a good T. Okay. I always like to do the cursive T's in math because so it doesn't look like a plus. All right. So then the first question here is, when does it get back to ground level? So the h out front is usually the height they're asking about. So I'm going to go ahead and plug in 0 right there. Okay, and so now we can solve this one. Now I can actually solve this one with just a GCF. So I would GCF a negative 16 here and a t, which would leave me with t minus 50. Remember, when you GCF a negative, it's going to flip the sign. Now, technically, we're supposed to set each of these equal to 0 and solve. So this one I would divide by negative 16. And this one I would say t equals 50. So in this one, it says, when does it fall back to ground level? So the t equals 0 right here is just saying like what we already knew. We started at 0. The t equals 50 right here would be my actual answer. All right, next one. When does it reach a height of 6,400 feet? So that one, I'm going to use that same equation and plug in 6,400 in for my h. Okay, so this one is a quadratic. Now we do need to get one side to 0. Last one, it was already at 0, so this one I need to get it to 0. Now I still kind of like my squared variable to be positive, so I'm actually going to move this all to the left. So we're going to say 16t squared minus 800t plus 6,400 equals 0. So I kind of moved everything to the left, so that switched the negative 16t squared to positive. Whenever you move stuff, it's going to switch. I did not switch the 6,400 because I didn't move it. Okay, I think these are still all divisible by 16, so I'm going to GCF a 16. I cannot GCF a t this time because that 6400 does not have a t. So it's going to leave me with t squared minus 50t plus, and what is 6400 divided by 16? I'm pretty sure it's divisible. Yeah, it's 400. And that equals 0. Okay, now we can factor the inside, so I need to think of two numbers that multiply to 400 and add to negative 50. And so I think that would just be negative 40 and negative 10, right? Yeah, I think that's right. Okay, so I can use this shortcut here since I don't have anything in front of that t squared. I can just call it t minus 40 and then t minus 10 equals 0. Now, when we have this GCF 16 out front, we do not set that equal to 0 because there's no variable. But I do say t minus 40 equals 0, t minus 10 equals 0. So t could equal 40, t could equal 10. And those are seconds. I should have said that here too. All right. Now, do both of those answers make sense? Well, actually, I think they do, because when will it reach a height of 6,400 feet? So you can kind of imagine this cannon is getting shot up, and it goes up and then goes back down. Well, it's possible that the height of 6,400 feet is kind of somewhere in the middle, so it hits it once on the way up and once on the way back down. So I think both of those answers are actually correct.